Okay, this is nice little logic LAN topology that we're actually going to be creating here. This is the diagram that we're going to be working with, and as you can see, there's actually 4 networks. We've got network A, network B, network C, and network D. Just above it here, it will actually state what type of point system you're going to get for each stage. So the designing elements, you could gain 35 points. Now this is an old practical practice paperwork, so it's okay to actually do. So what do we need? Well, we need Cisco, which will be provided, the switch will be provided, the computer. Now you only need 2 hosts for this, even though it just says 3. But you only need this one here, PC1, and also PC2. Actually, it's going to be PC1 that's going to do all the configurations, because this is the one that's got the console cable directly into the router. Okay, so moving down, and this is the scenario. And then we're just going to move straight on to task 1, design a logical LAN topology. Now, subnet A, it says as shown. So how many does that mean? Well, if we look at the network A, you can see that we've got a crossover cable directly from a PC straight to a router. So therefore, there's only a need for 2 IP addresses. So, in effect, where it says as shown, it should say 2. Okay, but you can work it out easily enough. And in subnet B, we need 3 to 6. In subnet C, we need 20 to 30. And in subnet D, we need 75 to 100. Now, you could pick any number in between them, but they're all going to be the same outcome. Okay, and I'll show you why. Okay, so how do we actually do the configuration? Well, you've looked at my VLSM for the C class, and hopefully you've got the gist of that. But I'll just briefly, verbally go through it again as I'm doing it. Okay, so there's our network, okay, which has been given to us, and it's a stroke 24. So that means we've actually got 8 bits to play with, which is the last octet. We can't change the first 3 octets. Now, when I look at these requirements here, my first thought is, which is the largest network required? And that's the one I'm going to work with first. And then I'll move down the scale, okay, until I finally get to this 2 network requirements here. Okay, so I'm going to work with D to start off with, subnet D. Now, the number of bits in the subnet mask, okay, so hang on a minute, I'm going to have to work this out, aren't I? Right. So if I move back up, and I can see that I need something between 75 and 100 hosts. So if I use my calculation correctly, as I move along, I can get 75 or 100 or any number in between into 128. So that's telling me that the network is going to go up in 128. My start point is going to be 0. But my next network will start at 128 because I need to have 126, because 75 won't go into 64. Okay, got me? Okay, good. So if I go back down to the D, and it says number of bits in the subnet. Well, if you put your line on the 128, that tells you that it's stroke 25. And therefore we've borrowed 1 bit out of the 4th octet. So you can either put 25, or you can put 1 bit, I will understand. Okay. Now, the IP masking binary. Okay, well this is going to be 255.255.255.128, because the 1 bit we've borrowed, if we look at that on the chart, it states that it is 128. If it was 2 bits, it would be the 128 and the 64. Okay, so that's the binary for the IP mask. New IP mask in decimal, okay, is this. Okay, let me just drop that down. I've just put it in the wrong place. What they're talking about the binary is once we've borrowed that 1 bit, then that becomes a 1. So under the 128 we have a 1. Well, it's just 128. We don't have to add the 64. We don't have to add the 32. So they're going to be zeros. So it's 1, 0, 0, 0, 0, 0, 0, 0. Okay. And if you wanted to put the first 3 octets, they would all be 1s. Okay. Good. Maximum number of usable subnets, including the 0. So if it's going up in 128s, this is where you've got to think about just the 128. Don't think about BLSM. Just think about the 128. How many 128 could we get in that C class if we were to break it down? Well, we can get 0 and we can get 128. But we can't get 256 because that's encroaching into the 3rd octet. So the answer for this will be 2. Number of usable hosts per subnet. Well, if it's going up in 128, we know we need to minus 2 because we have the broadcast address and we have the actual network address. So therefore, it is 126. Okay, what is the IP subnet? Well, this is the first one we've created. So it's going to be the 192.168.25.0. Now it's up to you. If you want to put the CIDR on the end, you can do. Okay, I'll just leave it that because we've actually got the subnet mask there anyway. So what is the first IP address? Well, 192.168.25.1. That's the first available IP address within this network. What is the last available? Well, it's going to be 126. 192.168.25.126. Why have I done 126? Well, the next IP address will be the broadcast address, which will be the 127. And then the 128 is actually going to be the start point for the next network. Okay. Right, so we know what our start point is for our next network. Okay. But we don't know how many we need because we have to find out how many bits we're going to borrow. So any number between 20 and 30, that tells me straight away that I need to go up in 32s. Well, I know my start point is going to be 128 because I've used that already. So 32 tells me that it's a stroke 27. So I'm actually using 3 bits. So if I go down, because I'm using the 128, the 64 and the 32. So 3 bits borrowed. What is the IP mask in binary? Well, if there's 3 bits, then it's going to be 3 bits. Okay, because I've got the 128, the 64 and the 32. Okay, what is the new IP mask in decimal? Well, it's going to be 255.224. Because if I add the 128, the 64 and the 32 together, it gives me 224. Maximum number of usable subnets. So get away from the BLSM element now. Think about it as a solid unit. Everything's going up in 32 and we're starting at 0. So we've got 0, 32, 64, 96, 128, 160, 192, 224. That gives us 8 networks. So your answer should be 8. Number of usable hosts per network. Well, we know it's going up in 32s, and we know we can't use 2 of them IP addresses, so the actual answer is 30. IP subnet. okay, is going to be the 128 because that's the start point. 192.168.25.128. And if you want to put the CIDR on there, you can do, which is 27. So that'll be a stroke 27. What is the first available IP address within this network? Well, it's going to be 129. What is the last available? Well, we know the next network is going to be 160 because if we add 32 to the 128, that gives us 160. We know the one before the next network is going to be the broadcast address. So therefore, the last IP address in this given network is going to be 158. Okay, so we've now done the actual C class. So we know the next start point is going to be 160, so now we can work on the class C. And the class C, we need 3 to 6. 3 will go into 4, but it won't minus the 2. So it doesn't matter, it's going to be 8 anyway. So it's going to go up in 8 because within this range here, it has to be 8. So how many bits have we actually borrowed if we're going up in 8? So we've got the 128, the 64, the 32, the 16, okay, and the 8, which is 29. Okay, so that's stroke 29. And that means we've actually borrowed 5 bits. So we've got 5 bits. So if it's 5 bits, we need 5 ones. It's as easy as that. So it's 1, 1, 1, 1, 1. And then 1, 2, 3 for the zeros. What is the decimalization for it? Well, we need to add the 128, the 64, the 32, the 16, and the 8 all together. Okay, which gives us an answer of 248, which is in the 4th octet. Maximum use of usable subnets within, so everything's going up in 8. So you can do this 2 ways. You can either divide the 8 into 256, or you can just go through it. Okay, so I think it's 64. Am I right? No, it's 32. Okay, so it's 32. If I'm wrong, please tell me. But if I get a calculator now. Okay, so we have 256 divided by 8. Oops. Let me cancel that. 256 divided by 8 equals 32. Okay, so the maximum is 32. Number of usable hosts per network. So if it's going up in 8, then we minus 2. And that gives us the amount of hosts we can put on that network. So it'll be 6. What is the subnet? IP subnet? Well, we know that it's going to be 160. Because this here is 159, the broadcast is 159, the last IP is 158, so that means that the next network is going to be 160. So this will be 192.168.25.160. And if you want, you can put the stroke 29, which is the CIDR. Okay, but we don't have to. So what's the first available IP address? 161. Okay, and the last available? Well, if it's going up in 8s, we know the next network is going to be 168. So the last available IP address in the range is going to be 166. Because the broadcast is going to be 167. Okay, so we know the next network is going to start at 168, so we can actually put that in here if we want. Okay, so what do we need on this? Well, we only need 2 IP addresses. So how many bits, number of bits for the subnetting? So 2 goes into 4, so it's going to go up in 4s. So that's the 128, the 64, the 32, the 16, and the 8, and the 4. We need to add all up together, and that will give us our subnet mask. So how many bits have we used? Well, we've actually used 6 when you count them: 128, 64, 32, 16, 8, and 4. So the number of bits borrowed is 6. In total, it would be 30. Okay. IP mask in binary? Well, as again, how many bits have we used? 6. So that is equal to 6 ones. 1, 2, 3, 4, 5, 6. And then 0, 0. New IP subnet mask. So it's going to be 255, 255, 255, 252. Okay? Because we add everything up from 1 to 8 right down to 4. Or the easier way of doing it is actually take 4 away from 256. Okay, there's 2 ways you can do it. Okay, so the answer to this is 255.255.255.252. Maximum number of usable subnets including 0. Well, I do believe this is actually 64, but I will just make sure I'm sure on that. So this time it will be 256 divided by 4 equals 64. So the maximum possible is 64. Number of usable hosts per subnet, well, it's going up in 4s, minus 2, so it's got to be 2. First IP address, well, it's going to be the first available within that network, 192.168.1. Oops, do apologize. Let's get rid of that. 25.169. And the last available will be the next IP address, because we're only allowed 2. Okay, and you could put the CIDR in if you want. You could have the stroke 30 on all of these 3 here. Okay, because the broadcast address is going to be 171. If we were to create another network, the start point would be 172. Quite right. Okay, so that's that element actually done. Okay, now what you would do is you would give host 1, okay, on the FA, so you'd need your design again. So you got FA00 here, okay, which is the network A. So that's going to be the host address is going to be 169. Okay, if we decide to have it as the first IP address, but I'm going to actually put this as 172. I'm just going to put .170. Okay, and then stroke 30, just to let you know where we're going. That's the mask, so I can just put stroke 30 in here, or I can put .252. I'll just work with the last track, and the gateway will be 169, which is the first given network, first given IP address within the network, and I'll put my stroke 30 there. Okay, now the router is going to be now don't forget, the router is the gateway, so it doesn't need a gateway address. So I can just copy this, okay, and put it there, because the router is the gateway. And then I've got host 2, so that's on the B, and that's going to be, the first IP is 161, so that's going to be the network. And we know it's going up in 8s, so that is 248 for the subnet mask, which is 29. So I can do all that. So 168, so it's 161. So I'll give this 162. 162 stroke 29. And that will be .248 and the gateway is going to be .161 stroke 29. And then just copy this again and put it as the router, because the router is the actual gateway. Okay, now if you've done it correctly, you should actually gain the full maximum points for this. Now if you can spot any problems, then please let me know. And you know what? That's looking pretty good. Okay, so that's that done. So the next stage will actually be configuring and then putting in after configuration each host record the host network settings with the ipconfig all command. So this is going into the PC and actually doing the ipconfig. I'm going to leave this section, okay, and then you've got your configuration of the router, and I'm going to do the configuration of the router in the next video. I hope this has helped you with the first stages of task 1, and thank you very much.